Imagine floating alone in the silent darkness of space, surrounded by countless stars. Ahead of you lies an object so mysterious that not even light can escape its grasp. It appears as a perfectly black sphere surrounded by a glowing ring of superheated gas, bending the light of distant galaxies into strange and beautiful shapes. This is a black hole, one of the most fascinating and terrifying objects in the universe. For decades, scientists have tried to understand what truly exists beyond its invisible boundary. Today, we begin an extraordinary journey toward the unknown. This is not just a story about space. It is a story about gravity, time, reality, and the deepest mysteries of existence. A black hole is born when a massive star reaches the end of its life. For millions of years, the star produces enormous amounts of energy by fusing lighter elements into heavier ones inside its core. This nuclear fusion creates an outward pressure that balances the crushing force of gravity. As long as this balance exists, the star remains stable. But eventually the fuel runs out. Without enough energy pushing outward, gravity takes complete control. In a matter of seconds, the core collapses with unimaginable force. The outer layers explode into space in a spectacular supernova, while the remaining core is compressed into an incredibly tiny region. If the original star was massive enough, nothing can stop this collapse, and a black hole is born. Despite their name, black holes are not empty holes floating through space. They are regions where matter has been compressed so intensely that gravity becomes almost infinite. Their gravitational pull is so strong that nothing, not even light traveling at nearly 300,000 kilometers per second, can escape once it crosses a certain boundary known as the event horizon. This invisible surface marks the point of no return. Anything crossing it disappears forever from the outside universe. As we continue moving closer, strange things begin happening. The stars behind the black hole appear distorted into glowing rings because gravity bends the path of light itself. This phenomenon, predicted by Albert Einstein's theory of general relativity, is called gravitational lensing. The black hole acts like a cosmic magnifying glass, warping space and time around it. Reality itself seems to twist before your eyes. Now imagine you are safely protected inside an indestructible spacecraft, slowly approaching the event horizon. Surprisingly, nothing dramatic happens at first. There is no giant wall or visible barrier waiting to stop you. The event horizon is completely invisible. If the black hole is supermassive, you might cross this boundary without even realizing it. From your perspective, everything seems normal. Your heartbeat remains steady. Your spacecraft continues forward exactly as before. Yet from the perspective of someone watching from far away, something extraordinary occurs. To the distant observer, your spacecraft appears to slow down as it approaches the event horizon. Every second seems longer than the last. Your movements become slower and slower until you appear completely frozen at the edge of the black hole. Your light becomes increasingly red and dim until it fades away entirely. To them, you never actually cross the event horizon. Instead, you simply disappear from view over an infinite amount of time. But inside your spacecraft, your experience is completely different. Time feels perfectly normal. You continue moving forward, unaware that the outside universe sees something entirely different. This bizarre contradiction is one of the most astonishing consequences of Einstein's theory of relativity. Time itself flows differently depending on the strength of gravity. As you travel deeper into the black hole, gravity grows stronger with every passing moment. The difference in gravitational pull between your head and your feet becomes enormous. Your feet are pulled much harder than the rest of your body. This stretching effect is known as spaghettification. Every atom inside you is slowly pulled apart along the direction of gravity while being squeezed from the sides. For smaller black holes, this process begins long before reaching the event horizon. For gigantic supermassive black holes, it may not happen until much farther inside. Outside the spacecraft, the universe continues evolving. Stars are born and die. Galaxies collide. Civilizations may rise and disappear. Billions or even trillions of years could pass while only a short amount of time passes for you. Gravity has become a machine that changes the flow of time itself. Eventually, every possible path leads toward a single destination called the singularity. According to Einstein's equations, this is the point where matter is compressed into infinite density and the curvature of space-time becomes infinite. Here, the known laws of physics completely break down. Our equations no longer provide meaningful answers. Scientists know this prediction cannot be the final truth because infinity usually signals that our understanding is incomplete. The singularity represents one of the greatest unsolved mysteries in science. Does it truly exist? Or is it replaced by something even stranger that we have not yet discovered? Modern theories suggest that quantum mechanics may completely change our understanding of what lies at the center of a black hole. Some physicists believe space and time themselves become discrete rather than continuous at extremely tiny scales. Others think singularities may never actually form. One of the greatest challenges in modern physics is combining general relativity with quantum mechanics. Relativity describes gravity on enormous cosmic scales, while quantum mechanics governs the tiny world of atoms and particles. Both theories work extremely well within their own domains, yet they refuse to fit together inside a black hole. Understanding what truly happens there may reveal a single unified theory explaining every force in nature. Another fascinating mystery involves information. According to quantum mechanics, information can never truly be destroyed. Every particle carries information about its history, but black holes seem to erase everything they consume forever. This contradiction became known as the black hole information paradox. If information disappears, quantum theory may be incomplete. If information survives somehow, then black holes are hiding secrets we have not yet uncovered. In 1974, physicist Stephen Hawking made a revolutionary discovery. Using quantum physics, he showed that black holes are not completely black. Tiny quantum fluctuations near the event horizon allow black holes to emit an incredibly faint form of radiation, now called Hawking radiation. This means black holes slowly lose mass over unimaginable periods of time. Eventually, after trillions upon trillions of years, even the largest black holes may completely evaporate. This discovery changed everything. Black holes were no longer eternal prisons. They could slowly disappear. But if they evaporate completely, what happens to everything that fell inside? Does the information escape through Hawking radiation? Is it stored on the event horizon itself? Scientists continue debating these questions today. Some theories suggest that the event horizon behaves like a gigantic cosmic memory, storing every piece of information on its surface. This idea inspired the holographic principle, which proposes that our three-dimensional universe may actually be described by information encoded on a two-dimensional boundary. If true, reality itself could be far stranger than anyone imagined. Other scientists wonder whether black holes might connect to entirely different regions of space through hypothetical tunnels called wormholes. Although no evidence currently confirms their existence, Einstein's equations allow such possibilities under certain conditions. If stable wormholes exist, they could connect distant galaxies or perhaps even different universes. However, keeping a wormhole open would require exotic forms of matter that have never been observed. Some cosmologists have proposed an even more astonishing possibility. Perhaps every black hole creates an entirely new universe inside it. Our own universe could have been born inside a black hole existing within another, larger universe. If this idea is correct, black holes may not simply destroy matter. They could become the birthplaces of entirely new realities. The first direct image of a black hole, released in 2019 by the Event Horizon Telescope, provided humanity with one of its greatest scientific achievements. By combining radio telescopes spread across the Earth, scientists created a virtual telescope nearly the size of our planet. The glowing ring surrounding the black hole in galaxy M87 matched Einstein's predictions with remarkable accuracy. In 2022, astronomers also revealed the image of Sagittarius A, the supermassive black hole at the center of our own Milky Way galaxy. Today we know that nearly every large galaxy contains a supermassive black hole at its center. Some contain billions of times the mass of our Sun. Rather than simply destroying everything around them, these enormous objects help shape the growth and evolution of entire galaxies through powerful jets of energy and enormous gravitational influence. As our journey comes to an end, we realize that black holes are far more than cosmic monsters. They are natural laboratories where gravity, quantum physics, and the structure of reality meet. They challenge every assumption we make about space, time, matter, and existence itself. Each new discovery raises even deeper questions than before. Perhaps one day humanity will develop a complete theory that explains what truly happens inside a black hole. Perhaps we will discover that singularities do not exist, that information is never lost, or that black holes are gateways to entirely new universes. Until then, they remain among the greatest mysteries in the cosmos, silently waiting in the darkness, reminding us that no matter how much we learn about the universe, there will always be places where the unknown begins.